Hello, I am Sabeeha Merchant, Professor of Biochemistry, Biophysics, and Structural Biology, and Professor of Plant and Microbial Biology at the University of California in Berkeley. My group studies the biology of trace metals, copper, iron, zinc, and manganese in the context of the function and assembly of the photosynthetic apparatus. These metals give chemical functionalities to proteins that cannot be provided by the side chains of the amino acids. 30 years ago, when I entered this field, this area of research was a black box. Today, we know that a significant fraction of the genome is dedicated to the biosynthesis and maintenance of metalloproteins. I use Chlamydomonas, a microbe, a green alga in the plant lineage, as my reference organism for discovery. Among our key discoveries is the occurrence of signaling pathways that allow life to adjust metal quotas in response to environment. We refer to that as elemental economy. I received the Gilbert Morgan Smith Medal in 2006 for discovery of the components of nutritional copper signaling, which involves recycling copper from photosynthesis and reusing it for respiration. We now know today that such signaling pathways operate for most of the inorganic elements, including sulfur, nitrogen, phosphorus, and the trace metals I mentioned earlier, copper, iron, zinc, and manganese. Life's chemistry depends on these elements, but in face of deficiency, life is resilient. The genome encodes backups and alternatives. Although we used classical genetic approaches for our original discoveries, comparative systems biology and genomics in the green algal lineage is the favored tool today. Just a few months ago, this approach led us to discover widespread polycistronic messenger RNA in eukaryotes, which we published, of course, in the Proceedings of the National Academy of Sciences.